Hi friends, in this video we will talk about sensitivity. So what is sensitivity? If there is any change in the system parameter, there will be some variations in the output. In other words, we can say that variations in the output due to the change in system parameter. This is the definition of sensitivity. Ideally, the base system is the one which is highly sensitive to input and less sensitive to noise and other disturbance. Now, what is the formula for sensitivity? We will see the formula for sensitivity with respect to open loop gain and feedback. So the formula for sensitivity with respect to open loop gain, sensitivity of a transfer function with respect to open loop gain is percentage change in transfer function by percentage change in open loop gain, which we can write as dou t by t by dou g by g. If we can manipulate this one, we will get g by t into dou t by dou g. Now let us see the sensitivity of a transfer function with respect to feedback. Here also it will be the same thing, percentage change in transfer function by percentage change in feedback, which we can write as dou t by t by dou h by h. Here it is a partial differential equation, which is dou, it's not d. We can write this term as h by t into dou t by dou h. Now we will find the sensitivity of open loop transfer function with respect to variation of g. For open loop system, transfer function is g only, and we know by our formula sensitivity of transfer function with respect to g is g by t into del t by del g. If we put here the value of t, we will get g by g into del g by del g. This gg will cancel out and del g by del g is 1. Now we can say that what do we know about sensitivity of transfer function with respect to g? It is percentage change in transfer function by percentage change in g equal to 1. So we can say that it is percentage change in transfer function equal to percentage change in g. What does it mean? It means that the system is highly sensitive. Now what is highly sensitive? Highly sensitive means it is sensitive to disturbance, noise and environmental condition, which means whatever the changes in the GS that directly affects the output. Now let us see the sensitivity of a closed loop with respect to variations in GS and HS. First we will see with respect to GS. So we know that closed loop transfer function is G by 1 plus GH. And we also know that the sensitivity of a transfer function with respect to open loop is percentage change in G, percentage change in transfer function by percentage change in G. The formula is G by T. Here we have derived the formula. So we write this formula only, g by t into del t by del g. So we put the value of transfer function here. So it is g by 1 plus gh into del g of g by 1 plus gh. We can cancel out gg. We will get 1 plus gh into, if we do the differentiation of this one, it is ddg of u by v. So v square v ddg of u, which is 1 ddg of g, minus u ddg of v, which is h. So we can cancel out this and this. It will be 1 plus gh minus gh by 1 plus gh. So gh cancel out. It will be 1 by 1 plus gh, which is equal to sensitivity of transfer function with respect to open loop gain. Now we will see for sensitivity of a transfer function with respect to feedback. From here we will take the formula. It is h by t into ddh of t. Again we will put the value of t here and here. H by g by 1 plus gh into ddh of t, g by 1 plus gh. It will be h into 1 plus gh by g into, now differentiation of this one, it is v square v ddx of u, it is 0, minus u ddx of ddh of v, it is g. So we can cancel out 1 plus gh. It will be h by g into minus g square 1 plus gh. If we cancel 1g, we will get minus gh by 1 plus gh. So this is our sensitivity with respect to feedback. Now we will see some examples. Here the question is, it is a feedback control system. Find the sensitivity of the transfer function with respect to variations in k. And the second part is, what is the magnitude at omega equal to 5 for k equal to 1. So now first of all we will find what is our g, means open loop gain. From here we can find g equal to 25 into s plus 1 by s plus 5 into k by s into s plus 1. We will see this method in our next video, which is block diagram reduction method. So we can cancel out these terms, then our open loop gain will be s into s plus 5. For now remember that if two blocks are there in series, then we will multiply. We will see this in next video. So it is our open loop gain. Now we need our transfer function. So transfer function is what? We saw that in our shortcut video that we can find the transfer function in 2 to 3 seconds. It's very quick. So what we did there, we have to add whatever there in the numerator in denominator. Then we will get our required transfer function, closed loop transfer function. After that we need, what do we need? Sensitivity of the transfer function with respect to variations in k. Means we need del t by t by del k by k, which is sensitivity of a transfer function with respect to k. If we simplify this one, it is k by t del t by del k. Now we will put the value of t here. It will be k by 25k by s square plus 5s plus 25k into ddk of 25k s square plus 5s plus 25k. Cancel this k, then we will get s square plus 5s plus 25k by 25. Now the differentiation of this one, it is v square v ddk of u, which is 25, minus u ddk of v, which is 25. So we can cancel these terms to this one, and from the numerator we can take 25 as common, so it will be s square plus 5s plus 25k minus 25k, and in the denominator it is 25 into s square plus 5s plus 25k. If we cancel these terms and these also get cancelled, we will get s square plus 5s by s square plus 5s plus 25k. This is our required sensitivity of transfer function with respect to k. Now the second part of the question is, what is the magnitude of this sensitivity at omega equal to 5 and for k equal to 1. So what we got, our sensitivity is s square plus 5s by s square plus 5s plus 25k. We know that s equal to j omega, so it will be j omega square plus 5j omega by j omega square plus 5j omega plus 25, and k equal to 1, so it is 25 into 1. Here it is j square into omega square, and we know that j square equal to minus 1. So minus omega square plus 5j omega by minus omega square plus 5j omega plus 25. And the value of omega is 5, so it will be minus 25 plus 25j minus 25 plus 25j plus 25. Cancel this 25. Now the magnitude of sensitivity is, which is this one, is minus 25 plus 25j by 25j. If we take 25 as common from here, we will get j minus 1 by 25j. Cancel this 25, we will get mod of j minus 1 by j. We know that if we have a plus j beta and we want the mod of this one, the magnitude is root over a square plus b square. So the magnitude of the numerator is root over minus 1 square plus 1 square, and the magnitude of the denominator is, it is j plus 0, so 0 square plus 1 square, which is root 2. This is our required magnitude at omega equal to 5 for k equal to 1. Now let us take one more example. Now in this question it is asked that to find the sensitivity of feedback control system where GS and HS is given. Here in this question we will use our direct formulas. Sensitivity of the transfer function with respect to G is 1 by 1 plus GH. So here forward path is G, so it is sensitivity of the transfer function with respect to G. It is 1 by 1 plus GH. here G is 25 by S into S plus 2 and H is 1 by 4. If we simplify these terms, we will get 4S into S plus 2 plus 25. In numerator it will be 4S into S plus 2. This is the sensitivity of the transfer function with respect to forward path. Now they ask to find the sensitivity at omega equal to 1. So let us put omega equal to 1. So how to put the omega equal to 1? We know that S equal to j omega. If we put here omega equal to 1, it will be 4j j plus 2, 4j j plus 2 plus 25. It will be 4j square, which is minus 1, plus 8j divided by 4j square means minus 4 plus 8j plus 25. Now we need to find the magnitude of this one. So the magnitude of this one is mod of minus 4 plus 8j by minus 4 plus 8j plus 25. So it is mod of minus 4 plus 8j by 21 plus 8j. So if we do, it is a plus j beta, a plus j beta. So we know that the formula is a square plus b square. Here also a square plus b square. So it will come 0.39. Now we will see with respect to feedback path, that is H. From here we know the formula is St of H is minus GH by 1 plus GH. We will use this formula here. St of H equals to minus GH by 1 plus GH. In our question, G is 25 by S into S plus 2 and H is 1 by 4. Here also 25 by S into S plus 2 into 1 by 4. So if we simplify this, what we will get? 4s s plus 2, here 25, 1 minus sign is there. 4s s plus 2, here it will be 4s into s plus 2 plus 25. So we will get 25 by 4s into s plus 2 plus 25. So we have to put s equal to j omega again for magnitude. S equal to j omega plus 2 plus 25, which is, and we have omega equal to 1 also, 4j j plus 2 plus 25. It is 25 by minus 4 means 4j square, it is minus 4 plus 8j plus 25, which is mod of 25 by 21 plus 8j. So now numerator is 25, denominator is a plus j beta, which is root over of 21 square plus 8 square. So it will come minus 1.11. So friends, It is our required sensitivity. So we know now how to find the sensitivity of a transfer function with respect to g, with respect to h, and with respect to k also, any other parameter. So friends, if you like this video, do like, comment, share, and please subscribe to our channel, Amra Backbenchers. Thank you.